Hello everyone, welcome to the kickoff video of the second assignment. We're going to take a look at the assignment description and the live demo of the program, but first we'll take a look at some organizational matters of A2. Assignment 2 is called the Intricate Square Placement. It's a game that is based on the strategy game Tico. The game you will have to implement is played on a square 5x5 board. There are 2 players and each player has 4 pieces. The goal of the game is to move your pieces in a certain winning pattern, and the first player that manages to do so is the winner. The game is structured into 2 phases. So at the beginning of the game the board is empty, and the first phase is this piece placing phase where each player can place their pieces on the board. Once the players have placed all of the pieces on the board, we switch over to the second phase, which is the shifting phase. And in the shifting phase, the players move their pieces 1 field at a time. Again, this phase continues until a player reaches a certain winning pattern or the game stops. The deadline for the second assignment is the 19th of November. So you are given roughly 3 weeks to complete this task. And assignment 2 is worth 18 points. The grading for assignment 2 is very similar to the grading of assignment 1. So 70% of those points are related to functionality. Again, we determine the functionality using public and private test cases. The public test cases you have access to, and the private test cases you only see how many of those you pass on our test system. The other 30% are related to code quality, and I want to emphasize, definitely make sure to check out the coding guidelines and the style guide on our course website on Notion. You can also get a few deductions again, for example by violating one of the specifications. The specifications you will also find on our course website. During the assignment interviews you can get deductions, and this time during the assignment interviews, this was not part of the assignment interviews for A1, you will be given a coding task, and in this coding task you will be asked to implement a small program, but you don't need to worry about this, it's just really a small coding task, and if you have solved A2 by yourself, you understand how your code works, you understand the learning goals, then this coding task will be no problem. Now this concludes the organization matters already, and now let's take a look at the assignment description. I have opened the upstream repository so I can show you the assignment description. For assignment 2 you will again get your own repository of the upstream, your own copy of the upstream, and this is where you should write your own code. Each student will get their own repository, and make sure you write your implementation in your own repository. Do not write your code in the upstream repository, because you cannot submit your solution there. In your repository for A2 you will find files similar looking to files that you have already seen in A1, with just one exception. This time we provide a framework. How to use this framework and what it is used for, I will show you in a second. But first let's check out the learning goals of A2. We have pointers and strings. We also have arrays, so to fulfill this learning goal, make sure to declare at least one array and use it in a meaningful way. There are command line arguments that must be handled. We will see very soon that there is one optional command line argument that controls whether the board of the game should be printed with or without color. Also make sure to use some constants. You can declare constants either using the define statement or by declaring a variable with the const keyword. In that case it's not really a variable anymore, it's a constant. Make sure to follow the specifications. There are some specifications that must be followed for every assignment, but you already know this from A1. For A2 there are no assignment specific specifications. I just want to mention that you are allowed to use any library as long as it's part of the C17 standard. Assignment 2 is worth 18 points, and you are asked to submit the file a2.c by committing and pushing before the deadline to your own repository. There are weekly exercises again. Make sure to solve at least 50% of those to not get a deduction. There are a few general notes that I want to highlight. The user input in general is case insensitive. That means that it doesn't matter how a command is spelled in terms of upper and lowercase. See those 3 examples of the quit command. All 3 of those should be recognized as a proper quit command, even though they are spelled differently. We have 2 players, so that means that we need to differentiate which player is asked for input now, and we do that by just writing P1 for player 1 or P2 for player 2 right next to the prompt. In assignment 2, you are asked to handle end of file properly. End of file is a constant and you can read from the standard input, and this just means that the standard input has reached its end. There will be no more input that you can find in standard input, and if you read this constant, make sure to terminate the program with an exit code of 0. You can trigger this end of file constant in the terminal using Ctrl and D on your keyboard. And if you read in end of file constant, make sure to terminate the program. End of file is really this constant and not the string EOF. So if you read in EOF as a string, this is not end of file, this is really just a string EOF that the user has entered, and in that case it should print invalid command and not terminate the program. A framework I have already addressed, but I will give you more info in just a second. Let's see how the game is started. As already mentioned, there is a command line argument. Command line arguments we can specify when starting the program. On the right hand side, I have opened a terminal in the upstream repository and pasted one of our reference solutions. So let's go ahead and quickly compile it. So we get the A2 binary, and if we now want to start the program and type one more space, we can now give a list of command line arguments. Each command line argument is separated by another space. So in this case, let's say ABC space df, I would try to start the program with 2 command line arguments, where ABC is the first command line argument and def is the second. ABC and def are not valid command line arguments for A2. We have only one optional command line argument, and this must either be disabled or enabled. So this would be a proper core to start A2. This would enable the printing of the board with color. I can now say disabled. This would print the board without color, and I can just omit it entirely and just start the program with A2. By default, the output is always without color. When starting the program, the user is greeted by this welcome message here, and right after the welcome message, the board is printed for the first time, so the empty board is printed at the beginning. Printing the board you can either do on your own, so the functionality of printing the board you can write on your own if you want to, but you can also use the framework. If you want to do it on your own, make sure to check out this printing the board section. Also pay attention to this section here, because you will have to print some pieces with color if color output is enabled, and how to print colored output to the terminal is explained here with those ANSI escape sequences. If you do not want to write this functionality on your own, let's check out the framework section. We have provided a framework to reduce your workload, and in this framework you will find a function for printing the board. This function is given in framework.c and framework.h file. Framework.h is the header file that contains just the declaration of the function, and framework.c is the source file that actually contains the implementation of that function. The function that you will find in a framework looks like this. It's called printBoard, and it takes a couple of parameters. First, the size of the board, and then the board itself, expected as a 2-dimensional array. While the framework expects a 2-dimensional array, You do not need to store the board as a two-dimensional array in your solution if you don't want to. But if you want to use the framework, you need at least to convert it to a dimensional array, because this is what the framework expects. But you're not required to store the board as a two-dimensional array. You can if you want to, and I think this is the recommended way of doing things, because it's rather easy to visualize the board game in a two-dimensional array. The third parameter is a flag whether color is enabled or not. And then we find two more parameters which are just codes for player 1 or player 2. So if we find this value in the board, the framework will print a field of the board as if it was owned by player 1. And if it finds this player 2 value in the board, it will recognize a field as if it was owned by player 2. If you want to use the framework, make sure to include or to write this include line at the top of your implementation file. It does not need to be the very first line, but it should be somewhere up here. So just make sure to put this line in your implementation file, and then you can call this function just like any other function, either a function that we have written by ourselves or printf, for example. It's just a function call that you need to do. Make sure that you do not modify framework.c or framework.h, because in the test system we will always replace those two files with the original files. So any changes that you make to those two files will be lost in the test system. Okay, let's jump back to playing the game, and let's first cover the piece placing phase. As already mentioned, the game is structured into two phases. At first, a phase where players must get rid of all their pieces. They need to place those pieces on the board. And then we have the shifting phase, where the players have already put all of the pieces on the board and they can only shift the pieces now. At first I want to show you the piece placing phase. So let's go ahead and start the game with color disabled in this case. And the only valid input that players can give now is one single coordinate. The coordinate consists of the column label at first, and then followed by the row label. As we see here, player 1 is now asked for some input, and let's just say player 1 places one of the pieces on A1. You can see here now that one piece was placed on A1. Player 2 is now asked for input, so you can see the players alternate turns. And player 2 places their piece on, let's say, B1 or something like that. And again, player 1 is asked. This is the piece placing phase, and this goes on until all of the pieces are placed. I will also want to show you that the input prompt, or within the user input, you should ignore all leading and trailing spaces. So I will type a couple of spaces here and say A2 and some more spaces. All of those should be ignored, and it should still be recognized as a valid user input. Okay, that's the piece placing phase. Now for the shifting pieces phase. This phase starts once the piece placing phase ends, and the users can now only shift their pieces one field at a time. I will show you this again, but let's start the program with color enabled now. And I will just randomly place the pieces somewhere just so we can switch over to the piece shifting phase, just like B1, A1, B2, A2, B3, A3, and now I will actually place the last two remaining pieces somewhere else so we don't already win the game. Just say D4 and D3 or something like that. And we have now reached the piece shifting phase. We can see that by the fact that remaining pieces, this section here is no longer printed now, because all players have placed all of their pieces. Now in the piece shifting phase, we expect two coordinates now as input. The source coordinate of the piece that should be shifted, and the target coordinate to the field where the piece should be shifted to. And of course player 1 can only shift their pieces and player 2 can only shift their own pieces. So player 1, let's say we want to shift d4 to c4, and player 2 will shift its piece c3 to b4, and shifting is only possible to one of the adjacent fields, so really only one field at a time. You cannot jump over fields. I'll show you a few error messages. For example, you cannot shift anything, or you cannot specify the first coordinate that does not point to a piece that you actually own. So if player 1 tries to move a3 to a4, you cannot do that because a3 does not contain a piece that you can actually shift. Also, you cannot try to shift a piece to a field that is already occupied. So p1 cannot move c4 to b4, for example, field at coordinates already occupied. And of course, you cannot jump over fields, so c4 cannot be moved to d1 or so. The target field is not adjacent to the source field. Okay, how do you win the game? The game can end, or how does the game end? The game ends either if the quit command is entered or end of file. In that case, the game just stops with return code 0. The game also stops if one of the players achieves a winning pattern. And these are the valid winning pattern here. So if a player manages to get all of the pieces in a straight line, either horizontal, vertical or diagonal, that's a winning pattern. Or if the player manages to get the pieces in a square 2x2, this is also a winning pattern and the game will stop. If player 1 wins, make sure to return exit code 1 of the program, and if player 2 wins, make sure to return exit code 0. So the return code or the exit code of the program is the return value of the main function. And now I'll just try to achieve such winning pattern. Player 1 cannot do it in one move, so I'll just do whatever, c4 to c3, but player 2 can win by shifting b4 to a4. In that case, player 2 won, and the return code of this program is 2 in this case. At the end of the assignment description, you also find the return values and error messages sections. Here you see which return values there are. I've already mentioned if the program is stopped with either quit or end of file, the return value should be 0. If player 2 wins, return value should be 1, and if player 2 wins, the return value should be 2. If the program is started with invalid command line arguments, the return value should be -1. And here you also find a list of error messages that should be printed if the user input is invalid. For example, an unknown command, if the entered command is not either a single coordinate or a double coordinate, or the quit command, it's an unknown command, and this message should be printed. There are also a few more error messages. Some of those I've already shown you. Some error message can only happen in one of the phases, and some error messages can also happen in both of them. Also make sure whenever you print an error message, print it with a leading and trailing empty line. Make sure you get those right, because you might fail some private test cases if you do not print the error messages properly. And there are also some example outputs that you can take a look at if you want. I also want to show you the test report. For that I will run make test in the upstream repository where I have pasted one of our reference solutions. We have 14 test cases, 7 are private and 7 are public. I'm just waiting for the test run to finish, then I will open the test report. And first I want to show you how to enable colored output in the test report. So I will switch to test case 7 because here we have colored output enabled, as you can see here. This was the command that was used to start the program. And by default, the ANSI escape sequences are printed. If you want to see the game pieces printed in color, just go ahead and press this button here, toggle invisible characters, and you will actually see the colored output. Another thing I want to address in the test report is the exit code sections. For A1 we have kind of ignored those because the exit code was always 0, but for A2 we have different exit codes depending on which player won or if the game was stopped with the quit command or enter file. So in test case 2 we see that the expected exit code was 0, so this is what your program should produce, and God is the actual exit code with which your program finished. Why is the expected exit code 0 in this case? Because the program was quit. For test case 3 we expect the exit code 1 because player 1 won the game. That's why the exit code should be 1. I also want to take a look at the memory usage errors and memory leaks. Now you might see some values here other than 0, and if you do so, that means you have some memory errors. If you do, just press on this open link here in the memory analyzer log, and it will open output that is generated by a program called Valgrind. And here you might see something like invalid read of size 4 or invalid write of size 4. This probably means that you have a buffer overflow, or you are reading from or writing to a memory section that you no longer have access to or no longer exists. If you see some errors here, just read those and try to figure them out yourselves. If you don't manage to do that, just ask on Discord and we will help you. One more thing I want to show you is how to compile the code manually if you're using the framework. And in general, we always need to specify our source file. So if we are using the framework, we need to specify our source file, a2.c, and the framework file as well, framework.c. Framework.c. That way the compiler works. If we just try to compile our source file and we are using the framework, it will tell us that we have no reference to the print board function was found because we have actually never compiled the source file that contained the implementation of the framework or of this print board function. We do not need to compile header files because header files are included. So always, if you want to compile manually, just make sure to specify all of the source files that you have. Back to the slides. I will actually skip a few slides now because we have already covered those, but it's just a brief summary of how the program is started, of the first and the second phase, and how the game is won. Also one more slide for how to include the framework if you want to use it. We have reached the end of this kickoff video. As always, if you have any questions, make sure to ask on Discord in the A2 forum. There will be another question hour a couple of days before the deadline at the same time as the question hour for A1, if I'm not mistaken. That being said, always check Discord for announcements, start early and write the code yourself. That way you will actually learn something. I wish you all the best for A2 and we will see each other again in the next kickoff video.